My name is Lars-Henrik. I work for a consultancy called BearingPoint, and I'm now a part of Payr's data science team. And today I'm going to give you a little introduction to the latest project that the data science team have been working on. It's called From Invoice to Insight, and it has the ambition of improving our customers' digital everyday lives by using information that we can extract from the invoices. After that, I'm also going to give you a little bit of an introduction to what the data science team will be working on in the coming weeks and months. So let's jump right in. You probably remember from Espen's presentation that Payr acts as a marketplace that connects businesses and customers by the invoices that the users pay using the app. And this matching of customers to products and businesses is strongly supported by the data science team, and it's something we have been working really hard on in the Invoice to Insight project. So this is an overview of what the Invoice to Insight process looks like. You can see it starts with an invoice being scanned using the app. It is analyzed using computer vision and machine learning. And within this process, the invoice is classified and it's put into one of our predetermined categories in which we offer better products to our customers, which hopefully results in an offer being made and a happy customer at the end of it. So the first step of this process is what we call the Ocr Scanner. As soon as the customer takes a photo of their invoice, it is uploaded to a computer vision API, which after some really quick processing returns all the key payment information on an invoice. Typically account number, the due date, the amount that you owe, and it automatically fills in this payment form, saving you the very boring job of doing this manually. This is already pretty nice from a customer service standpoint, but the data science team wasn't exactly happy with this. We wanted to see what else we could extract from an invoice that would help us generate better offers to our customers. So what else information is there on an invoice that we can potentially use? Well, from an invoice, we can learn what kind of product or service a customer has, how much they're paying for that service, and what type of payment that invoice was. So the possibilities here are quite big. So let me show you how we do this. This is what we start with. Way over here on the good side, we have the e-invoices. Those are what we really are after, because these have perfect text quality. They are really easy to read and understand. And in addition to just the payment information, they often contain a lot of additional information about the customer, or about the product, or about the customer's history with the company. A lot of information on this one that we can use for classifying our invoices. And a bit further down on the good scale, we have something that might look like this. Parking ticket. The text is really clear, it's visible, so it's easy for the computer vision to extract the text. But the invoice itself doesn't actually contain that much information that we can use to classify it with. And way over here on the bad side, we have this crumpled mess that's hard for even humans to read. Although computer vision now has become pretty good, it is still quite sensitive to simple things for us, like how the text is rotated, if there are any shadows or crumples or lines, and that can actually cause the vision algorithm to fail and not recognize the text at all, or output something really strange that we don't really understand. So the invoices are what we're really after. So what do we get from this? We get something that looks like this. Of course, this is something we can try to use machine learning on, but that is actually quite challenging. So what we would really like is to process this text into something that a machine can easily understand and that we can easily work with. So how we do that? We try to first remove all the Chinese characters that we see, and then we remove all the unnecessary words, very common words that don't actually provide any additional signal or value from the text. Then we remap all the letters, so we make sure all the letters are contained in the Norwegian alphabet. And after that, we use a lot of techniques from natural language processing, which is a specific subfield of the machine learning. So we use techniques like fuzzy searches, and we search for Levenstein distances, and we try word frequencies analysis, and we try word bagging techniques, And we also combine that with a more traditional approach, like searching for regular expressions. So what we get out of this is that we go from a very highly disordered data set consisting of images to something that's in a table form and very easy for us data scientists to analyze and try different machine learning models on. So we've learned a few interesting things so far. One of the first things that we found out was that the account number on an invoice is actually a quite strong predictor for many of the classes, so that we can identify which class an invoice belongs to almost singly by the account number. We also found another very strong predictor in words and phrases that appeared significantly more often in some classes of invoices compared to others. But perhaps the most surprising thing that we found was that specific company names, like this example here. This is an invoice for a medical service, a screenshot of an invoice for a medical service. But you can see we have way up in the corner Telenor. So if we fed this to our machine learning model, this would actually say, perfect, you found me a mobile service invoice, but it's not, it's for a medical service. So it's subtle things like these that you have to keep in mind when you try to get insights from your invoices. We have tried almost every kind of machine learning model, ranging from very complex deep learning neural network architectures all the way over to the opposite end of the scale and just say, try to describe or classify an invoice by using simple business rules. We actually had the most success with a model that's called support vector classification, and I'll try to explain this for you in an easy to understand fashion. What we start out with is what we data scientists refer to as training data. So that would be invoices that have already been classified. So you can think of one invoice as one point, and the color of that point is the class of the invoice. So with your training set, you try to teach the computer how to draw boundaries between all the different classes, right? So you want to put as many blue dots in the blue area as possible, as many white dots in the white area, and as many red dots in the red area. And you can actually see this is fairly easy for the blue dots. It works quite well. It's a bit harder to separate the white and the red ones. So how do we apply this to an invoice that we don't know which class it belongs to? Well, that's also quite easy. We save our optimal boundaries that we extracted from our training set, and we just plot our new invoice into this and see if it's in the white area, it's the white invoice, blue invoice, and red invoice. And it turns out we are correct in placing the invoice about 97% of the time. So to understand how this works in a bit more detail, we can have a look at this figure here. On the vertical axis, we have the actual class of an invoice, the class that it belongs to. And on the horizontal axis, we have the class that we predict that the invoice belongs to, which means that in a perfect world, we would have only positive numbers here along the diagonal, and we would have 0 everywhere else. That means that the model has put every invoice into the correct category. And you can immediately see that we are really good at finding out which invoices are consumer loans and which invoices are electricity. But we struggle a bit more with mobile phones and purchase financing products. There we have a bit lower accuracy. And we have several hypotheses of why this might be so. One thing we're looking into is that we now have several companies that now provide services within multiple of these categories. For instance, Fjordkraft offers both mobile and electricity, and same with Komplett, and same with Bank Norwegian, which makes it a bit challenging for us data scientists. It could also be that some of these invoice types actually don't contain enough information on every type of invoice, so that we don't learn enough from the training data just to see where is the boundary, what actually constitutes a mobile invoice compared to an electricity bill. But the real beauty of machine learning is that we continuously get more and more data, which means that we can retrain our models at regular intervals so that we continuously learn more what constitutes the different types of classes of invoices. So our accuracy is just going up and up and up. So what does the future hold for the data science team at Payr? Well, we have a lot of interesting things coming up, and I'll give you a little bit of an overview of one of the things we will be working on after Invoice to Insight. Just like everybody else, we are really excited about PSD2, the new payments directive, and all the open banking data that's becoming available. And one of the ways that Payr plans to use this data, along with data from other open sources, is that we try to make these beautiful and functional personal finance platforms that will not only just show your invoices, but also any other type of open banking data that you would like to connect to it. And when we get this data, we can try to develop models that predict your savings behavior, how much do you save every month, and also your spending behavior. How do you actually spend your money? What do you spend your money on? And based on that, we can give you financial advice that's tailored to you as a person. So that we can, for example, notify you if we don't have enough money in your account to pay your next invoice. That would be something we can do. Or we could recommend you a new credit card that will give you a better cashback in stores that you visit often, that you might not have thought of yourself. We can tailor these offers also to your personality type. If you are risk averse, maybe we wouldn't try to sell you the most aggressive credit card with the most bonus and the highest interest. So easy things like that we can do. And personality and digital humanity is something that we as data scientists really have to keep in mind going forward. Because it's really easy for us just to get buried in the numbers and just start thinking, what can we do to improve our accuracy scores? Or what new cool AI technique can we develop? Which is why it's so important for us to focus on the customer and how we can sort of identify what the customer really needs and how we can relate to each individual and capture all their individual needs and preferences. Sometimes it can be a little bit hard to keep in perspective that we actually work with real people when we only see the numbers. So we have to find creative ways to account for that. It is a challenge, it is very difficult, but we look forward to it, and it will definitely be important going forward. I think Gail will elaborate much more on this. I can't wait to hear what you have to say. So, thank you.